Good morning, students. This is your DRB Physics sir. Today our topic to learn is units, measurement, dimension. Units, measurement and dimension. So, if you think about unit, measurement and dimension, in physics it has a wide range of discussion. Point wise, first of all we will discuss units, then we will go to measurement and later on we will start dimension. Unit is what? A standard of measurement. Unit is a standard which is used to measure any kind of quantities like physical quantities, derived quantities, even we can measure any kind of angle. That's why it is called a standard of measurement. I can say this is a standard of measurement to measure any kind of physical quantities. To measure anything, we need unit. That is why before discussing in detail about the unit, we must know about the quantity also. To whom we are going to measure it. Measurement is what? To whom we are going to measure. The measurement is taking place whenever you are going to measure about the size of a body. Suppose I want to measure the weight of the body. I want to measure the speed of the body. I want to measure velocity of the body. I want to measure momentum of the body, I want to measure energy of the body, any kind of quantity I want to measure it. So, whenever I want to measure anything and it is measurable, then that is called as quantity. So, that means in physics we say anything which can be measured, nothing in this universe which is not measurable. I can measure everything, I can measure the pressure of the air, I can measure density of the body, I can measure electric current passing through it, I can measure the lightning falling, I can measure the size of the raindrops falling during the rain time. I can measure anything. That is why quantity, before going to think about the unit, let me discuss about the quantity. Quantity means what? Anything which can be measured. Maybe the size of the body, maybe weight of the body, maybe speed of the body, maybe velocity of the body, maybe work done produced by the body, maybe energy produced by the body, heat liberated from the body, radiation liberated from this solar spectrum. So, that is why all things can be measured. So, anything which can be measured, anything which can be measured with the help of a standard unit, they are called as quantity. Standard unit. Now I am using this word unit here. Whenever the topic comes the quantity means what? Anything around you, many things around us. In natural phenomena, many things around you. All the material things are around you, maybe in the solid state, maybe in the liquid state, maybe in the gaseous state, different state in materials are existing in nature. So, whenever you are going to measure the height of the mountain, so we are using a standard unit. Whenever I am going to measure the depth of the pond, depth of the river, depth of the ocean, also I am using the standard unit. That is why to measure anything around you, I mean to say natural phenomena, that means all quantity can be measured, anything which can be measured, they are called as quantity, but we are going to measure with the help of the standard unit, So, on the basis of the division classification, quantity may be divided into different types, maybe two type of measure quantities there. So, let us list out the types of quantities. There are in general, there are two types of quantity. I am writing here types of quantity. One quantity, first quantity is fundamental physical quantity. fundamental physical quantity. Second one, we can say fundamental derived quantity. Derived quantity. Okay. So there is two type of quantity generally. One is your physical quantity, other one is your derived quantity. What do we mean by physical quantity? You must know it. So physical quantity means what? All the quantity in terms of which law of physics can be described. Law of physics can be described, and all are measurable in terms of a standard unit. Whenever anything, any quantity are on the basis in terms of law of physics is explainable, or we are going to explain that one, they are called as physical quantity. What? Like we can consider the mass of the body. We can consider the mass of the body. Each and everybody having the mass. I have also mass, the duster also mass, chalk piece also mass. Whatever the things are around you, all are having masses. Mass means what? Anything, any quantity of matter contained in a body. Whatever the amount of matter contained in my body, that is my mass. Whatever the quantity of matter present inside the duster, that is its mass. So mass means anything which has its material, quantity of material contained in the body is called as mass. So mass is a quantity, and it is flowing in terms of the law of physics. That's why mass is a physical quantity, fundamental physical quantity. Similarly, I have listed mass is quantity. Secondly, I can consider length is also a quantity, time is also a quantity, temperature is also a quantity. Fifth, I can say electric current is a quantity. Sixth, luminous intensity also a quantity. 7, amount of substance is also a quantity. Like this, I have listed here the fundamental physical quantity are 7 types. There are mainly in measure 7 fundamental quantities are there. And also we are going to write down their units, standard unit by which they are going to measure or measurable. So if mass is the quantity, fundamental quantity, that unit is used to measure is kilogram. Unit is used to measure kilogram. The SI unit is kilogram. I can say kg, the short form. Now the length is measured with the unit which is called as meter. Symbolically, it is m. Time period is second. Symbol is S. Temperature is Kelvin. Symbol is K. Electric current is ampere. Symbol is A. Luminous intensity is candela. C-A-N-D-E-L-A, candela. Please note it. Candela is, your symbol is CD. Amount of substance is mole. MOLE, mole. The symbolically we can write MOL dot also, there is no problem, MOL. So like this, here we have listed 7 fundamental quantities and there are 7 corresponding units. So what happened? These are called as what? Your quantities, and with the help of these quantities, we can describe to measure the natural phenomena which are following or in terms of the laws of physics. In our nature, in our natural phenomena, whatever things are measurable, so mostly they are belongs to this type of quantity. And with the help of this quantity, mass, length, time, whenever we are expressing any other quantities are expressed. These are the fundamental physical quantities, these are the base quantities. This mass, length, time, I can say this is the base quantity. With the help of mass, length, time, if I am able to measure any other quantity can be measured, then they are called as other quantity, none other than derived quantity. I have listed here types of quantities. One is fundamental physical quantity, second one is what? Derived quantity. So here, after 7 fundamental quantity and their corresponding unit, we must remember that whenever mass, length, time is used to measure any kind of quantity or we are deriving the other quantity, then they are called as what? Your derived quantity. So, that means what? Mass, length, time. I may give another name also, special name. This mass, length, time is called as base quantity. This is called as base quantity. For an example, I want to construct a building. So, what happened? I have to give a foundation, base must be strong. Suppose whenever you are continuing your study up to 11th class, now you are studying 11th class, that means what? Your base must be strong from standard 1, standard 2, standard 3. Then when base is strong, then you can do excel in your exam in 11th class. You can understand the 11th class syllabus or studies, whatever may be. Like this, whenever any other quantities we are going to derive it, like speed of the body, like area of the body, like volume of the body, like density of the substance, like fresh air, work done, energy, whatever things around you, and we are deriving the quantities, that with the help of these quantities only we are going to derive it. With the help of this temperature, with the help of electric current, with the help of luminous intensity, amount of substance. So, basically whenever we are going to give a structure, dimension of the body, then these three quantities like mass, length, time only called as base quantity. So, not only mass, length, time are the fundamental physical quantity, we may give another name, mass, length, time is also a base quantity. With the help of mass, length, time exceptionally or exclusively mass, length, time, after using of this, we are going to derive a structure of a body, shape of the body, size of the body, that is called as dimension of the body. So, let us discuss about the derived quantity. Once again, derived quantities are those quantities which are expressed in terms of fundamental physical quantity, in terms of mass, length, time. So, please write down the derived quantity. These 7 fundamental quantities and their units are very, very important. It comes in the exam. 2 mark, 3 mark questions will come. What are the different fundamental quantities? Write down their units. So, 3 mark questions there. Please remember. And when next class I will come, I will interact it, recap. I will ask the question, what are the 7 fundamental quantity units? You must remember that. Okay. Now, the type of quantity is derived quantity. Second quantity, we are discussing about derived quantity. So, once again, it is very simple word. Derived means what? We are expressing with the help of others. Deriving. Matlab, we are expressing this quantity with the help of other. We are deriving. That means what? Derived quantity means what? With the help of mass, length, time. With the help of fundamental physical quantity. Those quantities are expressed. They are called as derived quantity. Like, for an example, speed. I am talking about speed. Speed means what? This is your distance upon time. The ratio between distance and time, or distance upon time. So, you feel that distance means what? It is a scalar quantity, path covered by the body. It is scalar quantity and path covered by the body and time period, you see. So, this distance is what? Itself is a length or not? Distance itself is a length and time divided by time. Now, you see me. So, whenever we are discussing about the 7 fundamental quantity, length name was there. I was talking about mass, length, time, electric current, temperature, so and so. So, here length is your what? Which quantity? Physical quantity, fundamental physical quantity. Time also fundamental physical quantity. That means what? It is the expression. Speed is the expression or derived from the ratio between length and time. That means length is a physical quantity, time is a physical quantity. With the help of length and time, with the help of fundamental physical quantity, I am expressing speed. So, speed is a derived quantity. Speed is called as derived quantity. And what about this length and time? Length is a physical quantity, then time is a physical quantity. Both are physical quantity. Similarly, if I express about another quantity, let it be volume. I am giving example, very simple example I am giving. Then you will learn the length. Volume means what? The product of length, breadth and height of a structure of a body. So, length of the body, length, I am multiplying with breadth and I am multiplying with height also. So, now tell me, length is which quantity? Fundamental physical quantity. I can write length symbol L. Breadth is what? This is length of this duster. This is the breadth. This side is the breadth and this side I can say this is your height. So, here length into breadth the B into height H. Now clear? So breadth means what? I am writing symbol B, but itself is a length. Height also I am writing H symbol, but itself is a length. That's why what? I am writing L into L into L. That means what? That means this is the L to the power 3, L cube. Now tell me, whenever I am talking about volume, then it is nothing but the cube of the length. What is length? Length is a fundamental physical quantity. So with the help of length, with the help of physical quantity, I am expressing a quantity like volume, and volume is your derived quantity. What is that? Volume is your derived quantity. That means another third example I am giving, that is, suppose acceleration. Acceleration is what? That is the rate of change of velocity. That you know in the standard school level, you know, acceleration is the rate of change of velocity. Whenever the body is increasing the velocity, increasing the speed in a particular direction. Suppose my speed, suppose for an example, I am giving here, the body is at the A, now at the B position. The body is moving, traveling. At the A, whatever the speed was there, velocity was there, that is your U. U is the velocity. Whatever the changes comes, now at the B position, the final velocity is your V. That means I am at the position, I am moving with 20 km per hour speed. Now at the B position, I am at the 50 km per hour speed. Now, so initial speed is 20 km per hour, initial velocity, and final velocity is your 50 km per hour. So I am increasing the velocity, and to cover this T time period required. T time period required. So this changes. What is changes? Final velocity, difference with the initial velocity with respect to time period T. So V minus U by T is your acceleration, and it is also a vector quantity. That means rate of change of velocity. What is V minus U? Final velocity minus initial velocity. This changes is called as what? Changes is velocity. Difference is called as changes of velocity. Final velocity minus initial velocity divided by time period. So V minus U by T is equal to acceleration. I am talking about that acceleration. So acceleration is rate of change of velocity. That is why V by T, symbolically I am writing V by T. I am not putting here vector symbol because we are going to put the value. That's why. Now what is velocity? Velocity is equal to displacement by time. Velocity means equal to displacement by time. So I am writing here S by T. Displacement by time, S with an arrow mark, that is separately I am talking about displacement, then velocity is equal to displacement, this is S arrow mark by T, right. So here displacement of time, and already I have a T, whenever I am writing the acceleration velocity by T. So V is equals to S by T and whole divided by T, that is S by T square, S by T square. Now you say what is S? S stands for, I am writing here for displacement. Displacement itself is what? Is a length. Magnitude of displacement is a length. So here I am writing L by T square. L by T square. Now you see acceleration is a derived quantity which is expressed with the help of length and time. That means length is a physical quantity, time is also a physical quantity. So I am using binary operation. Suppose division symbol is there, square is there, cube is there, whatever things, binary operation will come. Addition, subtraction, division, multiplication will come. But quantities are what? Quantities are length divided by T. There are time period T for time period, L for length. That means what? I am using the length and time. In terms of length and time, I am deriving a quantity. That quantity is called as acceleration. So that means what? Acceleration is a derived quantity which is expressed in terms of the physical quantity like length and time. So my dear student, that's why the derived quantity are those quantities which are expressed in terms of physical quantities, in terms of base quantity, and so many lists, so many names are there in the derived quantity. If we give the example of derived quantity, let me write. So 5-6 example I am going to write. That is area is a derived quantity. Volume is also a derived quantity. Then density is a derived quantity. Suppose I can say force is a derived quantity. Work done is a derived quantity. Energy. Suppose kinetic energy is your derived quantity. Kinetic energy is formula is what? I will discuss later on. Kinetic energy is half mv square. Work done is your force into distance. Area is equal to side square. Suppose L square. Volume is equal to L cube. Density is equal to mass upon volume. Force is equal to mass into acceleration. force applied by anybody is mass into acceleration. So, whenever we will discuss about the detail, then after I will in dimension case I will go to detail. Now, kinetic energy like this one etc. So many quantities are there, whatever the things what in physics, the applications are always based on these derived quantities. And how the derived quantities we got, that we have explained. So, with the help of in terms of physical quantity, fundamental physical quantity like mass, length, time, we are expressing the quantity, that quantities are here area, volume, density, force and etc. are called as derived quantities. Here what happened after this fundamental physical quantity and derived quantity, I must tell another units also there. Another units also there, that units is called as supplementary units, which is very important also and it comes in exam. You must remember this supplementary units. In supplementary units, after physical quantity and derived quantity, so you should remember supplementary quantity, or I can say supplementary quantity. It is not a quantity, but we used to study that supplementary quantity means angle. Angle is your supplementary quantity. It is dimensionless. It has no dimension. It has no structure. It has no mass, no length, no time period. Only the variable is there. This is no dimension, dimensionless, and the valuable variable. So, here angle means what? Angle means any angle. Suppose you can see the wall, some angle is there. Triangle is there. Suppose I can measure the triangle, it has 3 angle. I can measure a rectangular figure. Suppose it has an angle, a 90 degree are there. 4 angles 90 degree. Pentagon, hexagon, any kind of suppose structure is there. So, we can find in geometry, in mathematics, we can find angle. So, angle means what? The ratio between an arc upon radius. Arc upon radius. Arc means what? Suppose this is a circle. Suppose this is a circle and I am taking origin A here, O, and this is here. This O is what? Radius. Now, another point on the circumference, this is B point. Suppose this is your OB. OB R, OA is also R. Both are radius. Radius means any distance between origin and any point on the circumference. Now, AB. So, this AB is called as an arc. Here AB is called, according to this diagram I can write AB, arc means AB, and radius means what? R for radius I am taking. So, this is called as angle and this is the symbol used for the angle is theta. This angle is theta. So, like this angle is a supplementary quantity. Generally this angle is 2 type. We will get 2 type of angle in all around you, that is to measure. The angle is 2 type. One angle is, suppose types of angle I can consider. So, this is angle 2 type my dear. One is your plane angle, one is your plane angle we can consider, and other one is your solid angle. How many angle I told? One is plane angle, other one is solid angle. There is 2 type of angle. And in geometry also you will find in physics anywhere, engineering studies, in suppose whenever you will study medical also, here you will get different terms related to angle. Plane angle is measured. Plane angle is measured in radian. In radian unit. In radian unit. So, if theta is the angle in radian, theta is the measurement of radian. So, it is called as an arc divided by your radius. Before I have told in the definition of angle. So, theta radian is the unit to measure the plane angle. Is the plane angle. Whenever you are going to construct 60 degree, 30 degree, 45 degree, 90 degree, that a plane angle, 2D, 2-dimensional structure, 2-dimensional angle we are measuring, that is plane angle. It is measured in a radian unit. What is the unit of angle? Plane angle, radian. Similarly, solid angle is measured in steradian. It is theta. Here I will write steradian. Symbol for angle is theta in both cases. In radian also theta, in steradian also theta. So, here steradian you can say, okay, and steradian is equals to, again I can write this is your area by radius square, surface area by radius square. radius square. This is your steradian solid angle formula. That is steradian. What is that here? Arc by radius, radian angle. Here steradian. Steradian is area of the surface divided by radius square. Area is equal to A. A is the area of anything. Suppose a circle is there. A circle, what is the area of the circle? Pi r square. If it is a circle, then pi r square is the area. Okay. And what happened? This is area by radius square, r square I can write. So, angle is two type. One is plane angle, other one is solid angle. Plane angle measured in radian. Solid angle measured in steradian. Plane angle is expressed that theta is equals to arc by radius. Steradian is theta is used to represent by area upon area radius square. So, this is about your quantities. It is about your quantities. So, now before I told that before using this unit, talking about the unit, we must remember about the quantity. So, I have explained physical quantity, derived quantity, and again supplementary quantity or units. Now, my dear, then whenever anything is there, suppose a theta I am using the that is unit to measure the angle is theta. Unit to measure the angle is theta. Supplementary unit is theta. Then this is the unit standard to measure any physical quantity. Standard is used, any standard is used to measure the physical quantity is called as the unit. The short definition I am taking. So, unit is the standard, any standard used to measure the quantity. So, what is the standard then? Suppose for your understanding I am telling that standard means what is a step, it is a step of measurement, the level of measurement. Suppose I can't measure, suppose for an example a small piece of gold, I can't measure in kg, kilogram. If you go to any shop or goldsmith, then you have a small piece of gold and you will ask the goldsmith and uncle how much weight will be there and give me the price. So, he will not going to measure by kilogram, gram. So, milligram will use. Milligram is the unit to measure the small pieces of gold like this. So, milligram, gram, then kilogram, then I can use ton, quintals, kilogram after quintal, then tons. These are all units to measure mass. All are the unit standard used to measure mass. So, what happened? Situation on this is depending upon the situation. It is depending upon the situation. Suppose for an example, I am going to any grocery shop then to bring some sugar. Suppose I went to your home. Okay, mommy asked that sir is coming and let's prepare the tea. Then you are going to shop and grocery shop, and he is asking, "Beta, how much sugar I will give?" You are going to tell 250 gram, 100 gram, because in your home nobody is taking tea. Okay, so gram they are using. Suppose for an example, in your house, suppose rice and all other things are grocery materials are coming in kilogram, kg will coming, 25 kg, 50 kg like that. And whenever you are going to do any function, celebration, you are doing the celebration, marriage celebration, birthday celebration, or any other business you are doing, then what happened? We are talking about the quintals. I have to stock in my shop. The quintals of materials are there. And whenever the big business is going on, then tons. Okay, suppose export import time, that is tons. So, this is what? This is also the standard of mass. This is also a standard used to measure the mass. So, milligram, gram, kilogram, quintal, tons, these are all the measurement of the mass. Unit used to measure the mass. So, these are the standard. Milligram is also a standard of mass, standard of measurement, and gram also a standard of measurement. For what? For to measure the quantity like mass. So, for an example, again I am talking about the unit of suppose another quantity, mass after length. Suppose I am talking about the length. So, you must understand what is the use of unit in different related quantities. Length means, suppose for an example, what I can say, suppose I want to measure this length of this duster, radius of the duster, diameter of the duster. It is the very smallest thing is there. Okay. So, what happened? I can again like this I can use the microcentimeter, micrometer. 1 micrometer is equal to, in physics I can say 10 power 6 meter, suppose is 1 micrometer. Micro is very small, macro is very small. Then what happened? Microcentimeter, centimeter I can use, millimeter I can use, millimeter, micrometer, millimeter, centimeter. Suppose for an example, I want to measure from this distance to this distance. So what happened? Maybe some meter is there. You will tell, sir, this is 1 meter, 2 meter, 3 meter is there. So what happened? Meter unit I have used is a standard. Meter is a standard which is used to measure the quantity like length. Micrometer, microcentimeter also small standard level steps of measurement. For which quantity? Length like quantity. Like this, after meter, what I can think? Kilometer. What is the distance? Where are you coming from? From Puri. What is the distance between Puri and Bhubaneswar? Maybe 60 kilometer above. Yes or no? So 60 kilometer I am talking. 60 kilometer. So kilometer is this one. Suppose I want to purchase one land. Suppose in Bhubaneswar I am staying for a long days. So what happened? I want to purchase the land. So what happened? Acres. Acres also what happened? It is a standard or used to measure the length. Acre, square feet, square feet. Now what happened? These lands are available in square feet. This much of square foot, this much of amount. So that means what? All these things, miles, acres, square foot, these are all the standard of measurement for length quantity, for the quantity like length. So here also mass, standard units are different level. So milligram is one level, gram is another level, kilogram is another level. Here also micrometer, millimeter, centimeter, meter, kilogram, kilometer. These are all one level. Whenever you require that standard, we have to use that unit. Suppose for an example, suppose I am going to work from this position to this second bench. Suppose to you I am going. So what happened? I can't say that this much of kilometer I work to you. I will tell how much meter I can work to you, right? So that's why what happened? You have to depend, we have to express or you have to think about the standard whenever you are going to measure the quantity. That's why I am telling unit is the standard used for measuring any physical quantity. I think it is understood. Suppose for a very interesting thing is there, time is there. Okay, time is what is very important. That time never waits to anybody, not to you also, not to me also. For an example, I want to do a sound, that is, what is this? This is a chutki, suppose. So what happened? एक चुटकी what happened? बजाने के लिए तुमको कितना वक्त चाहिए? A very smallest time period, microsecond maybe. Okay. So what happened? The microsecond, this time period required to do something else. Okay, I want to what happens? Do a sound. I want to strike upon the table, bench. That means what? Microsecond required. Suppose for an example, one clock is there. Now a clock is there. So what happened? Second hour is tick 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 is going second. Suppose for an example, I can talk about the second is the unit of another standard to measure the time period. Sir, how much minute you are going to teach further? That means when you are talking about the minute. Suppose my teaching is you are getting bored. So many times sir is teaching. Let sir is to go outside. So you are talking about the minute, you are talking about the hour, you are talking about the days. Sir, so many days we are in the holiday, that is due to COVID-19. So days, we are talking about the days. We are talking about the month also. Month also is unit of time. Year also unit of time. Decades also unit of time. One decade is how much year? Tell me. Yes, very good. 10 years is called as one decade. Again, I can talk about the century, 100 years. That is after millennium, 1000 years. So what are these? These are all the unit standard used to measure the time period. So please remember the mass, length, time. What quantity? Physical quantity I told. To measure this physical quantity, so many standard used for measurement of this. That means what? To measure the mass, milligram, gram, kilogram, so and so is there. To measure the length, there are so many microcentimeter, centimeter, meter, kilogram, acres, so square feet is there. That means what? The units are only is used for measuring your physical quantity. It is a standard. It is a standard used for measuring a physical quantity. That's why it is very, very important whenever you are going to measure the physical quantity. Without the help of standard for measurement, without the help of unit, can you measure any quantity? No. Without the help of or support of this expressing the support of the unit, we are not going to measure anything else. We can't measure anything. That's why the fundamental physical quantity, the derived quantity, even supplementary units, all are depending upon the standard or used to measure the quantity. That is called as unit. and you have to depend upon unit. So basically in physics, what happened, there are different types of the units. We are going to talk about that units. Now the key points we are going to start. The units are different type of units. Let us say this is MKS unit, this is CGS unit, or I can say FPS unit, or I can say SI unit. Like this, different units are there. Now if you think laboratory, suppose in wide view, we will talk about, sir, what are the types of unit? So I can say these are the MKS, CGS, FPS. In the early classes you have learned this. So what is the full form of MKS? This is meter kilogram second. Meter kilogram and second, very fundamental thing. This is centimeter, gram. I think some students get bored, or you are interesting, listening. This is foot, pound, second, and this is a very important and very special unit, that is SI. So in books it is written, or I can say standard international the unit, standard international, in different books, different full form is there. So let's write standard international the unit. Standard international the units. Now meter kilogram second, centimeter gram second, FPS unit. Generally whenever you will pass 12th class, you will study engineering study, basically in engineering study FPS units are used, foot, pound, second. If you go to foreign, suppose a small baby get born, so how much pound of baby is there, like this people says. So this is pound, we are measuring the mass in terms of pound, okay. But here what happened, MKS unit and CGS unit are widely used, meter kilogram second, centimeter gram second. But unfortunately what happened, whenever many quantities are there, it is not possible to measure with the help of meter kilogram second or centimeter gram second. It is a conversion. Suppose 1 meter is 100 centimeter, 1 kilogram is 1000 gram. So like this, MKS CGS unit is not sufficient to measure the quantities. Suppose I want to measure electric current. Can I measure by MKS? I want to measure the luminous intensity. I want to measure the amount of substance. I want to measure the temperature of the body. So meter kilogram second, centimeter gram second is not able to measure the quantity like current, temperature, intensity. So that's what happened. The scientists, they thought that a standard international unit must be adopted or used, so that international level we can measure all kind of quantity, all measurable quantity, all quantity can be measured with the help of SI unit. That means I am teaching here, suppose in your class, suppose this is Bhubaneswar. So what happened if you go to London, also say SI unit is adopted. If you go to Australia students also, that they will take, what is the unit of force? Newton. They will not take a different word. So like this, the SI unit or standard international unit is used. That's why whatever unit, again I am recapping this, mass, length, time, electric current, 7 fundamental quantity, whatever I will listed. So what are the unit? Unit of mass is kilogram, unit of length is meter, unit of time period is second, unit of current is ampere, unit of temperature is Kelvin, luminous intensity is candela, amount of substance is mole. Like this, these units are all called as SI unit. They are called as system international units. So that's why now you understood what are the different types of units and we measured. Then all quantities, whatever it is measured, like may physical quantity, derived quantity, supplementary quantity, whatever may be. So each quantity, each thing having the what? Dimension, structure. Dimension or structure. What is that? Let us give the heading about dimension. Suppose I am talking about the area. Again I am repeating. Area is what quantity? Derived quantity. It was derived quantity. I was expressing area as length into breadth of something. Length into breadth of something. So area means what? Square of the side. Suppose I am talking about a square, this all sides are same. So this is side square, a square is the area of this square. So length into breadth, product of any two sides is called the area. So what happened? This is your length L, this is your breadth also I can write L. I am not going to write suppose I am not writing B here, breadth for B is usually written, but here L. So what is this, my dear? This is L square or not? Again I am remembering this is the physical quantity, base quantity, length, area is the derived quantity. Now in this format what happened? I am going to get this dimensional structure. What is the dimensional structure? So the physical quantity and the power is here. So dimension is what? The raising power of physical quantity. The raising power of physical quantity is called as dimension. Raising power of physical quantity is called as dimension. Here, please tell me. Now area is equals to L square. What is L? Physical quantity. What is 2? It is a power. So physical quantity to the power 2. Here L is the physical quantity, 2 is the power. So 2 is the power or not? Exponent. So this power is called a dimension of the area. Hence this definition is what? Raising power of the physical quantity is called as dimension. So I want to calculate the dimension of the area. Think about the dimension of the area. Now area explained like this, L square. So L is what here? L is the physical quantity, 2 is the power of this physical quantity. So I can say 2 is the dimension of this area. 2 is the dimension of the area. So like this, suppose I am using another quantity, I think you will understand properly. Suppose take a example of speed. Speed, velocity, area, volume, yeah, these are the common quantities for your understanding where you are going to use. Speed is what? Distance upon time. Distance upon time, right? Now very interestingly you can say this is a length per time. Length per time. Symbol let's use, this is L by T or not? L by T. L by T. Suppose I am writing here that is LT minus 1 I can write. LT minus 1 I can write. So here what is the L power 1? What is the T power? Minus 1. That means these are the dimension 1 minus 1. The dimension of length and time for measuring speed. So before that dimension you must know about the rule regulation to express the dimensional power, dimensional analysis. So no doubt dimension is the raising power of the physical quantity, and we are going to use this base quantity and symbol mass, length, time. Mass for M, length for L, T for T, time for T. So this is an order of this dimensional format. We are not going to write LMT, we are not going to write first T then L, so it will wrong. So here we are going to write this M for mass, L for length, T for time in this format, and M to the power A, L to the power B, L to the power T to the power C, A, B, C, X, Y, Z, whatever you can write. So here the quantity mass and A is this dimension, quantity length and B is its dimension, quantity T and C is the dimension. So A, B, C is the dimension. किसी भी quantity नाम लिखो इसमें quantity. Suppose I am writing here any kind of quantity and इसका dimensional power is equals to like this. Dimensional format is equal to like this. Let us write then the previous example I am talking about the suppose velocity. I am not writing speed because same thing will come. Velocity I am writing. Suppose velocity is a quantity. Okay. Velocity, what is the formula? Previously I have written this is the displacement by time. Displacement by time. Displacement upon time. Displacement symbol I can write L, time symbol I can write T. So what symbol I will get? This is your L, T, you will go to numerator, this will be minus 1. Now L power is equal to 1. Here no mass is there. Let me write mass. अगर कुछ भी नहीं है तो 0 dimension है, 0 है. It was there is LT minus 1, but I am writing mass because whenever I am going to mass, then 0 power I write because we know x to the power 0 is equal to what? 1. Nothing will change. उसका जो product we are not going to change it. So M0 L1 T minus 1 is the dimensional formula of this displacement, and we should put a square bracket, then it will be correct presentation. Whenever we are going to write a dimension, then velocity square bracket, within square bracket I have written here, and displacement also within square bracket, time period is also square bracket, and now I am writing here m0 L1 t minus 1. So, how to write 0 1 minus 1 are the dimension of velocity in terms of mass, length and time. 0 1 minus 1 are the dimension of the velocity in terms of mass, length and time. Okay. Now, after one example I will finish the class. Okay. You are getting bored. So, now let us think about another example, acceleration. Let us start for acceleration. So many dimensional formula is there, you have to practice it. So, acceleration is what? Your acceleration is your velocity upon time. Velocity upon time. So, velocity is equal to what? Your displacement by time, this one. So, directly I am writing here, suppose m0 L1 t minus 1, and what is time? In which will come t. Now, finally you write here, write on it, what will happen you see? T means what? T to the power 1, t to the power 1. So, let me erase this. Now, please write down quick. Okay. Can you write like this? Suppose I think in denominator there is no mass. So, it is m0 L1 t minus 2. This is your dimensional formula of this acceleration. What are the dimension then? 0 is the dimension of mass, 1 is the dimension of length, and minus 2 is the dimension of time period. So, what I can say? 0, 1, minus 2 are the dimension of the quantity like acceleration. Or someone is asking, suppose what is the dimensional formula of the acceleration? I can say m0 L1 t minus 2. Okay. Then we can say this is L1 t minus 2. Suppose someone is writing like this also, it is correct, because for complete format I have written m0. So, we can omit it also, m0, nothing is there. So, directly we can write L1 t minus 2 is the dimensional formula of the acceleration. So, like this we can express dimensional formula of the acceleration and other quantities also there. In next class we will discuss about all the dimensional format, what are the different list of the quantities I will give and their dimensional formula. Minimum 20-30 dimensional formula you have to remember for your exam. Okay. Thank you. Next class we will discuss about the rest things about the dimensional formula.